In this video, we will show a video of the Rube Goldberg machine we created in class. We will then explain the physics behind both it and what is happening during the run. This is our Rube Goldberg machine.
Go.
For this project, we will be explaining and showing how parts of our machine exhibit the following: kinematics, forces and Newton's laws, projectile motion, energy conversions, work, and momentum. When the initial ball is rolling at the beginning of the machine, it is at a constant velocity. In this example, the ball rolls at a constant velocity before it runs into the Hot Wheel car. On the other hand, changing acceleration is present in our project when the ball rolls down the ramp. The ball comes out of the ramp at a faster speed than which it entered. To show two objects changing motion, at the beginning of our project, a compressed spring is released, applying an unbalanced force to the neutral metal ball. Our project also shows an object experience a constant net force during the inelastic collision between the Hot Wheel cars. The cars push each other with an equal amount of force and also move as a singular unit. At the end of our Rube Goldberg project, the cup of vinegar is launched off a textbook by the ball, representing projectile motion. The components of the velocity of the vinegar are in two directions, x and y. It accelerates in the y direction as it nears closer to the ground, but has a constant velocity in the x direction due to a lack of acceleration after the initial force from the metal ball. The wiffle ball has gravitational potential energy right before it rolls down the ramp. Once it descends down the ramp, this gravitational potential energy becomes kinetic energy because the ball is now moving. In the beginning of our project, there is elastic potential energy prior to the ball starting when it is in position to be launched. Once the compressed spring is released, the elastic potential energy is converted to kinetic energy as the ball begins to move. Towards the end of our project, the ball rolls towards a liquid matter in a cup, vinegar. While the ball rolls towards it, it has kinetic energy. The elevated cup of vinegar has gravitational potential energy. This potential energy increases as the kinetic energy in the ball becomes gravitational potential energy in the cup just before it falls. An elastic force does positive work when the launcher moves the initial ball. Gravity then does positive work when the next ball begins to roll down the ramp. Our project represents a perfect elastic collision when the metal ball hits the Hot Wheel car. After they collide, they do not stick together, but bounce off one another. This slows down the ball and speeds up the car, conserving total momentum. The two Hot Wheel cars hitting one another and then sticking together show an imperfect inelastic collision because they do not bounce off one another. This conserves total momentum as they move as one unit. Our project shows a rotational collision when the ball comes out of the ramp and hits the wall/curve. This puts a spin on the ball before it crashes into the dominoes, conserving total momentum. Energy enters the system through the launch of the ball by the spring launcher. This initial work begins the energy that flows throughout the rest of our project. Energy exits the system through the chemical reaction between the vinegar and the baking soda at the end of our project, as well as the vinegar hitting the plate.